Welcome to clickmyproject.com. Our product title is Control of Ripple Eliminators to improve the power quality of DC systems and reduce the usage of electrolyte capacitors. Let us see about the abstract of our product. The problem of voltage and current ripples has become a primary power quality issue for the system, which could seriously degrade the performance on both the source side and the load side, and lead to reliability concern. In this proposed design, a single base pulse width modulation controlled rectifier is taken as an example to investigate how HU control strategies can improve the power quality of DC systems, reduce voltage ripples, and at the same time reduce the usage of electrolyte capacitors. The concept, the literature is further developed and the ratio of capacitance reductions is quantified. Quality problem with such ripple eliminator. This power quality problem is formulated as a control problem to actively traverse the ripple current on the DC bus. The main focus of this proposed design is to investigate how advanced control strategies could improve the performance of ripple. An advanced controller on the basis of the repetitive control is proposed for one possible implementation of ripple eliminators in the continuous current mode conduction, and also that results are to verify comparison to another ripple eliminator operated in the discontinuous current mode. It has been shown that the proposed instantaneous ripple current diversion leads to a nearly four-fold improvement of performance. Next, we see about the flow diagram of our process. In this proposed flow diagram, the input source is a AC source. That AC source is a single base AC source. Then that source is fed into a single base PWM rectifier with ripple eliminator circuits, and also those controller is used to trigger the single base PWM rectifier switches, and finally the output of the PWM rectifier is fed into the load. The load may be a resistive load or inductive or capacitive load. In electrical engineering, single base electrical power is the distribution of alternating current. Electrical power using a system in which all the voltage of the supply vary in unison. Single base distribution is used when loads are mostly lighting and heating with few large electric motors. A single base supply connected to an alternating current electric motor does not produce a revolving magnetic field, and is a single base motors need additional circuits for starting, and such motors are uncommon for starting about 10 kW in rating. Single base AC power systems peak in voltage at 90° and 270°. A cycle combines at 360°. All electrolyte capacitors are polarized capacitors whose anode is made of a particular metal on which an insulating oxide layer forms by ionization. Acting as the dielectric of the electrolyte capacitor, a non-solid or non-solid electrolyte which covers the surface of the oxide layer in principle serves as the second electrolyte cathode of the capacitor. Due to their very thin electric oxide layer and enlarged anode surface, electrolyte capacitors have based on the volume. Much capacitors have based on the volume of higher capacitance voltage product compared with the ceramic capacitors. Next, we see about the running process of our product. In this proposed implementation, the design is done in MATLAB simulating environment. First, open the new model file. After opening the new model file, the main window will be open. Then the elements is getting from the simulating library browser. From the simulating library browser, two main blocks is used. One is the simulating power system block, another one commonly used block. From that block, so we getting the elements, then arrange the elements as per the circuit diagram and also given flow diagram. Then that scope is connected to the output areas. The scope is getting from the commonly used blocks. So after connecting that elements, then click the run symbol, then corresponding output will be displayed in the corresponding connected scopes. First one, the input AC voltage, the value is 220 volt. Next one, the current waveform of in the rectifier side, and next one is also current waveform in the capacitance side, and this is the output voltage waveform in the DC side. So around 400 volt is the output of the DC side, and this is the output voltage waveform for another side. This is the output current waveform. So the overall current and voltage is depends on the connecting load. So the output voltage is converted into DC, and also is less ripples. So this efficiency will be increased. Thank you for watching this video.